So let's take a look at acid-base titration. So what does it mean? It's something you've done before a lot of times already. Simply means that it's an acid will be alkaline to form the titration. So I'm not going to read through one by one the point. I just want to highlight some key things. There are two different things you need to know. One solution is in the burette. The other one is called in the conical flask. So the one in the burette, we have a name given to this. We call it titrant. Okay, remember you see this word in enzyme, it represents the burette. The one in conical flask is called titrant. So this is a very different wording, although the difference between them is the D and the T. So make sure you know the difference between them. Now nowadays we no longer call the neutralization point. We call it as the equivalence point. So whenever you hear the word equivalence point, it is the same idea as neutralization point. Right? They are exactly the same. So don't get confused by this. Now we move on. So can I say that you also need to put indicator for your experiment so that you know the end point. So there are many different types of indicator. So just give you your experiment setup. As you can see, these are some of the things you are familiar with. Nothing special. So let's take a look at the next page. So we have many different types of acid-base titration. So far we only learned strong acid, strong base, but actually there's other type of titration as well. See, besides strong acid and your strong base, you can have strong acid, weak base, or vice versa, weak acid, strong base. You also can be weak acid, weak base, but the good thing is this is not in syllabus anymore. Now, do you need to memorize the graph here? No, you don't need to memorize the graph if you have not learned the chapter called acid-base equilibrium. Later, when you reach the chapter of acid-base equilibrium, then this is the point we will teach you more in specific how to derive the equation of the graph and how do you draw it from the start to the end. It's very, very simple. Now let's take a look at some of the information, like the choice of indicator. Now there are many different types of indicator, but which are the two that's most important in exam? The most important is methyl orange and phenolphthalein. So methyl orange, remember you see the word orange is like red like that, so you always detect your acid. So that means that, right, if the endpoint is acidic, use methyl orange. Phenolphthalein, you see the word A-L-E-I-N, sounds like the word alien. Alien is a bit weird, so you'll be alkaline. So if at endpoint you put in excess 1 drop alkaline, that will be using phenolphthalein. So that means that, right, if your burette is acid, you will use this guy. So if your burette is alkaline, then you use phenolphthalein as an indicator. So remember, burette is acid, methyl orange. Burette is alkaline, use phenolphthalein. That's all. The rest of the thing, do you need to memorize? No, because right, normally they will provide you in exam. So I need you to put a pause on this video, go ahead and try to check on the next page so as to recap some of the information that you learned before earlier part in the years. Alright, let's take a look together on one question. So we have a titration experiments. 20 cubic cm or 0.2 mole per nickel NaOH reacted with 32 cubic cm of sulfuric acid solution. Calculate the concentration of H2SO4 in mole per dm cube and in gram per dm cube. So what I like to do the first step is I write down equation. This is the H2SO4 we have NaOH equations. Find the number of moles first. The number of moles of your sodium hydroxide, it should be 20.0 cubic cm or 20 over 1000 times 0.2, you get a number of moles. After that, I know the mole ratio is between 2:1. So I divide by 2, I get a number of moles of sulfuric acid. I divide it by the volume. The volume is how much? 32 cubic cm. So divided by 32 over 1000 is 0.032. So you get a concentration. And let's take a look at number B. So B, I want to find out in gram per dm cube. I find the mass first. After I find the mass, which is the molar mass, I take the mole per dm cube, cross multiply with your molar mass, then you get gram per dm cube. Now keep in mind, remember your mole multiplied by mR, it will give you a gram. So this is what we are doing here. Do not be confused by the dm cube. Ignore the dm cube. Just focus only on the mole as well as your molecular weight. That's how you get your mole, how you get your gram per dm cube. Now let's move on to something a bit more challenging. So we have one example here. So a solution of an acid contains 25.2 gram of your diacid. This is diacid, dot SH2O per dm cube. 50 cubic cm of this solution requires 40 cubic cm of 0.5 mole per dm cube or KOH for titration with phenolphthalein as indicator. Calculate the value of X. So I'm supposed to determine the value of X here. So what I do is I find out the molar mass, it will be 90, which is here, plus 18x, because this dot here represent 18. This dot here represent plus. This H2O is 18, so 18 times x. I want to find the concentration. I do know the mass, so I take the 25.2 divided by the total molecular weight. Then you may ask me, why your mass divided by your molar mass is equals to mole per dm cube? Because it tells me that this is 25.2 per dm cube. So this is actually what essentially your gram per dm cube here. This is gram per dm cube. So you see they hide the word like that, right? This is gram per dm cube. That's why gram per dm cube divided by molecular weight is mole per dm cube. Next, KOH. Can I say that you know the volume, you know the concentration, you can find the moles. And after that, I can write a very simple equation. Now, don't forget it's diacid, so therefore you need 2 hydroxide to react with the diacid inside to become CO minus K plus bracket 2, because you got 2 of them inside. Then plus X plus H2O, because this bond will be broken apart into crystals. So this is X here, but you produce 2 moles of H2O because 2OH reacted with 2H. So it's 2H2O. Then so it's X plus 2H2O. Then from here, I will be able to determine the number of moles of your acid. So you know the moles of this one, divide by 2, you find the number of moles. Then can I say that you want to find out the concentration of this compound here? How do I do it? So I find the concentration, very simple. You take the mole divided by the volume. You see this one is 50 cubic cm. So you take the mole divided by the volume, 0.2 mole per dm cube. After you get the concentration already, can I say that this also represents your concentration? So this concentration, you go to 0.2. This one is obtained from earlier partner. So you cross multiply, solve x, and it's equals to 2. And that's how you solve the answer.